Hi, and welcome back to MBA PodTV. I'm your host, Mia Saini. Today we're running through a tricky GMAT math problem with Manhattan GMAT instructor Jonathan Schneider. So take out your pencils and your notebook and get ready.
Hi, my name is Jonathan Schneider. I am an instructor here with Manhattan GMAT. I scored a 780 on the GMAT about 2 years ago. I've been working for Manhattan GMAT for the past 2 years. I've done a lot of our online courses, and I also teach in person and do live tutoring here in New York. I'm going to be leading you on a math problem today. Take a moment and look over this slide, and if you'd like to pause it so that you can try the problem on your own, feel free to do so. Okay, so as you'll notice here, there are a couple of different ways that we can begin a problem like this. One thing that people will often try to do is approach this with direct algebra. And that's very possible, and it's a great solution, but you have to know how to manipulate that algebra. In terms of deciding how to represent this as an equation, we first need to deal with x%. In terms of working with a variable as a percent, simply think of the word percent as meaning over 100. X% then simply translates to x divided by 100. Of y%, the of always means multiplication, and we do the same thing where we put y over 100. From there, we take of z as meaning times z. And in this way, we can begin our translation. Now, after this point, we have to determine what it means to be reduced by y%. And a reduction is very similar to how we would think in terms of day-to-day pricing. This is something that we can all do on our heads. Representing it mathematically with variables is a bit more challenging. We can try to multiply by 1 minus y%, and that will capture the decrease of y%. The 1 stands in for the original value, and the minus y%, or in this case minus y over 100, represents the decrease, and that becomes our entire expression. Now at this point we have a very complex expression, and it doesn't match any of our answer choices. So from here we have to manipulate this a little bit further. And what you'll see that you would like to try at first is to combine these denominators into a common form. In doing that, you have to make sure that you combine in such a way that you can take these two parts across the subtraction sign and get them to have the same denominator. That is going to allow us then to combine everything into one simplified expression. Now it's fairly easy to combine on this first side, and you'll see that you have over 10,000 from the two 100s. Noticing on the second side though, we have this over 100 3 separate times. This is going to give us a denominator of 1 million. And we need to create our first fraction in such a way as to agree with that second fraction. We need to, in other words, create the denominator in the first fraction as 1 million also. In order to do that, and to keep the same value, we need to also multiply the numerator of that first fraction by 100. And this is what allows us to get to our final answer, where we have a 100 multiplied by the first polynomial in the numerator. Of course, I mentioned that we have an alternate approach here as well. We could pick numbers. Now, in order to do that, we want to be able to pick smart numbers, numbers that are going to work conveniently for this problem. We oftentimes want to approach a problem this way when we have variables in the answer choice. It's going to allow us a simplified form without having to set up complex algebra. Now, in order to do this, we want to pick a smart number, and we want to start with the number 100. But you have to know what to pick that for because we have 3 variables here. In this problem, it's going to be easiest to pick 100 for z, because z is the starting value. And then pick other smart numbers for x and for y. A smart number for y might be 50, because 50% is simply 1/2, and that is going to be easy to calculate. We could furthermore take x to be 10, and then we would simply be taking 10% of 50% of 100. And we can do that calculation out quite simply. Now, after that point, we need to think about what a 50% decrease would mean, because again, we've chosen y as 50. So simply take a 50% decrease of the number that we've reached so far, and you'll see that we end up with a target value. Now, this target value is something that we can use to look for in our answer choices. All that we need to do is attempt to plug in each of our chosen values into the expressions in the answer choices and see where we come out with a match for our target value. Ideally, we'll only come out with one match, and that will be our answer. Of course, sometimes we do hit two or more choices that match, at which point we have to choose new numbers, or at least change one of the numbers, and try the system again.
Wow, working that GMAT problem gave me flashbacks to when I took the GMAT 5 years ago. So don't put your notebooks away just yet. We have many more problem-solving exercises from both the quantitative and verbal sections of the GMAT. Well, that's it for this edition of MBA Pod TV. I'm your host, Mia Saini. Visit us at mbapodcaster.com to get the latest audio and video shows, and follow us on Facebook and Twitter to get the latest news and insight on your MBA application process.